very much. And really, really pleased to be here and to talk to you today about a subject that's become very timely over the last year or so. Before I begin, I also just want to acknowledge that I'm speaking to you today from my office at the University of British Columbia, which is situated on the traditional and unceded territories of the Musqueam people. I'm really, really grateful to be able to work in such a beautiful place in the world, a really stunning campus, and I actually try and get outside and enjoy it every day that I'm here. Today, however, we're going to be talking about indoor air quality, and as many of you are aware of, for most individuals in high-income countries, we spend upwards of 90% of our time indoors in the places where we live and work. So today I'll be talking to you about the issue of gas stoves and how they relate to both exacerbation of respiratory disease, information on their links to causing asthma, so incident asthma, also information on the climate impacts related to gas appliances in homes, and then talk at the end a little bit, or actually throughout a little bit, about the role of nitrogen dioxide, and in part relating that to some recently revised World Health Organization air quality guidelines. Many of you may be aware of these guidelines in reference to outdoor air quality. However, they are actually applicable in all environments. They're health-based guidelines. These are not legally binding standards, but is an attempt from the World Health Organization to actually review in a non-sort of regulatory, non-political context, what is the health information indicate relating to the concentrations and harmful impacts of air pollutants in all environments. And I was pleased to be able to participate in the development of these guidelines. So I think many of you are aware of this issue has been in the news recently. I'd like to start out just unpacking a little bit of what happened. There was a initial, not even really a full report from the U.S. Consumer Product Safety Commission that was reflecting on health issues related to gas stove use in homes, and this got sort of taken up by the media. There was some, I would say, musing about a ban, although very quickly sort of very clarifications that there was no intent to actually ban such appliances in U.S. homes. But of course, this very quickly got into the media and very quickly also became political. Gas stoves are used in about 35% of U.S. households. I wasn't able to find recent data for Canada, but from the child study, so a cohort study that is relatively recent, about which is over sampling high income, higher educated homes, about 25% of the households in that study in Canada use gas for cooking. So it's a very prevalent type of cooking appliance in our homes. There was a report from a number of environmental NGOs that looked at literature values for concentrations of nitrogen dioxide. And again, I'll sort of distinguish between gas stoves and nitrogen dioxide throughout. That's an important distinction. Making the case that the levels that are measured in homes during cooking events exceed many air quality standards and air quality guidelines. Actually, what's shown here are rather old guidelines. So this was taken up by a number of NGOs. I'll just give you some of my own background on the issue. This is actually, this is also a paper that came out about 2 years ago, and it's really talking about all the issues related to use of fossil fuels and use of gas. So as all of you are aware of, fossil fuel use and combustion is a major if not the major contributor to climate change. In this editorial in the New England Journal of Medicine, the authors also in their what I would say is really an advocacy piece against the use of fossil fuels in general, also mention the health impacts related to gas combustion and their generation of oxides of nitrogen. Again, there's that distinction, focusing on oxides of nitrogen, and literature that increases asthma risk and aggravates chronic obstructive pulmonary disease, or COPD. So my own history actually starts when I was in graduate school in the 1990s, and shortly thereafter, with a colleague, Susan Kennedy, we wrote this commentary in the Lancet, which was reflecting on a study that was published again at this time. So this is 1996, a long time ago. And I'll just mention what we wrote then. We said that the relationship between respiratory health and indoor air pollution from use of these appliances, both for cooking and heating, has received considerable attention during the past 25 years. So this now goes back into the 1970s. At that time, studies showed both positive and negative associations. Most of the positive studies indicate that the effect is relatively small. So relative risks of around 1.2, which are rather difficult to detect without very large samples. But this is still an issue of major importance, really because of the high prevalence of exposure. So even a relative risk that's rather small, if exposure prevalence is high, so if many people are exposed to that risk, that can still be consequential from a population health perspective. So again, this is not a new issue at all. So we said it was an old issue in 1996. And I'll have to say that since 1996, since we wrote this quote, there's been very little that's changed. I will try and point out sort of what the new information is, but really the studies are still very inconsistent, and the effects that we are measuring in these studies are rather small. But of course, we do have more information. What is new is really more on the climate angle rather than a health angle. And this has undoubtedly been the driver for much of the attention, especially from NGOs and also from municipalities. And I'll talk more about that in a second, to think about actually either bans or regulations or bylaws about removal of gas stoves or no new gas cooking appliances in new home construction. This is a study done by Rob Jackson and colleagues at Stanford, and they looked at methane and nitrogen oxide emissions from gas stoves and ovens in residential homes. And the important new bit here is emissions of methane. So what they measured was that quite high levels of methane when the stoves were turned off. So this is a leakage from the gas piping that feeds the stove, and you can see here the dark blue line. So there's methane even when the stove is turned off. The levels go up when the stove is turned on. The nitrogen oxide levels are essentially zero until the stove is turned on, and that's very clear. Why is this important? Well, methane is a very potent climate forcing agent, and it's also really the target of a lot of efforts right now to reduce emissions because it's short-lived in the atmosphere, meaning that if you reduce emissions from the atmosphere, you actually get a very quick benefit in terms of temperature. So if we can reduce methane from all its sources, methane emissions, we can actually very quickly reduce some of the impacts of climate, which essentially buys us time as we move towards a fully decarbonized economy where we're also having to deal with the focus on combustion and carbon dioxide. So in their analysis, they estimated that the annual methane emissions from all gas stoves, and again, most of this is due to when they're off, have a climate impact comparable to the annual CO2 emissions of more than 500,000 cars. So really a substantial issue there. This coincides with bylaws. So for example, where I live in Vancouver, in new low-rise residential buildings, they must be zero emissions, meaning no new gas appliances for space heating or hot water heating in our construction. And several municipalities, and the most prominent is Berkeley, California, which had a ban in place until last week or so. I think just 2 days ago it was thrown out, their ban on natural gas in new home construction. And this is thrown out because of jurisdiction over who governs use of fuels, not anything to do with sort of the health angle. So this is still an issue that's very much in the forefront. Again, most of this is driven by climate concerns, but on top of that, there's been a lot of attention on the health impacts. And so one other issue which does relate to health, this is a study looking at, again, unburned samples. So this is just the feedstock for a gas appliance across 7 geographic regions in California. And I should have said, so when we're talking about natural gas, most of that is methane, but there are contaminants to that gas supply, and a number of harmful constituents have been measured in the, again, unburned natural gas in this study, and in particular emphasis on benzene, which is a human carcinogen. Again, these are in the gas itself. When the gas is actually burned, there are measurable levels of benzene, but it's highly dependent on the burn conditions, the ventilation conditions, the space of the location where it's being used. In this study, they also found very large differences actually in the benzene content of the gas, depending on where it was sourced from. So which company and actually where, which sort of gas field and pipeline it came from. So I think there's much more to come about the potential health impacts of benzene in natural gas, and whether this is really an issue of concern, or whether the levels are extremely are too low. So I think more to come on that. In the work I mentioned earlier from the group at Stanford, as you can see again in the lighter green here, when the stove is turned on, you do get increasing and relatively high levels of nitrogen oxides. Their data very consistent with, again, data that's been available since the 70s, that if you are using a natural gas appliance, especially without using a range hood or low levels of ventilation, no open windows, for example, in a kitchen, you can surpass the US National Air Quality Standard, which is 100 parts per billion, or around 53 micrograms per cubic meter within a few minutes of stove usage. Again, very dependent on the particular circumstances. I will come back to this, but this is also relevant because of these new World Health Organization annual air quality guidelines, which indicate much lower levels. And just to put these sort of in context, so these are now suggesting an annual average exposure of 10 micrograms per cubic meter, 24 hours of 25. These are both lower than the current residential exposure limits for nitrogen dioxide in Canada, and even lower than the Canadian ambient air quality standards, which are in turn actually lower than the US ambient air quality standards. So basically what we're seeing is that the levels that we can measure in use of gas cooking appliances in homes, again, highly dependent on the conditions, both in the short term and even in the long term. So long-term averages can exceed these health-based guidelines. So what has been driving all this recent attention is this paper. This is a paper that really took no new information, but put two different pieces of data together. One is information on the proportion of US households that use gas stoves for cooking. This was based on surveys from 9 different states. You can see actually across the states that were surveyed, the prevalence, which is primarily driven, since the relative risks that they use were exactly the same, the prevalence or the attributable fraction, what proportion of asthma were they associating with gas stove use, is entirely due to the level of gas stove appliances in homes, and that varied a lot, over 7-fold between Florida and the US. And they took previously published relative risks from a meta-analysis that was published more than 10 years ago, basically put those two pieces together and came up with the estimate that about 13% of the childhood asthma in the United States could be attributable to gas stove use. And again, varied by state from 3% to 20%. So this is the meta-analysis, and you can see two things here. So, there's one is the random effects and fixed effects. They're looking both at current asthma or lifetime asthma, but just focusing on current asthma, a 40% increased risk of incident asthma. So this is development of new asthma in children associated with the use of gas for cooking. You can also see, if you look across the studies and you just look at the dots, the point estimates, there's a lot of variation between studies, and then within studies also quite high uncertainty. So this is not a very well-defined relationship. When you see a lot of heterogeneity across studies, it suggests that there are other factors that are likely contributing to this relationship. So studies that are actually showing no effect or even a protective effect, is studies that are showing quite large effects. The authors of the meta-analysis, I'm just summarizing their conclusions here in their own words, that children living in a home with gas cooking had a 42% increased risk of having current asthma. Related to NO2 levels, for each 15 part per billion increase in the levels, there was a 15% increased risk of having current wheeze, but actually no relationship between asthma and NO2 levels, and no increase in the risk of wheeze in relation to gas cooking exposure. So again, wheeze being something that is often more prevalent in individuals with asthma. The sort of relationship between wheeze and asthma was not the same for NO2 or for gas cooking. So they also looked at whether across all the studies, did the effects for gas cooking, did they vary geography or other parameters, and for example found that the effects in Europe and the Asia Pacific were larger than North America. So that may relate to differences in cooking practices, differences in home design, differences in who is actually using gas cooking and who is not. They found higher effects where gas cooking prevalence was low, so where gas cooking was not that common. And they also found higher effect estimates for earlier studies. And I think this is very important, because many of the earlier studies were on gas stoves that had continuously lit pilot lights. So you're actually having a flame burning all the time, compared to most stoves, certainly nowadays and even over the last 20 years or so, where there's a spark ignition pilot. So you only have a flame burning, only have emissions of nitrogen oxides or any combustion products when you're actually using the stove, which is a much shorter period of time. And that's actually been backed up by measurements. So when you have continuous pilots, you have a constant level of NO2 emissions. Where do we get the NO2 from? For those of you who aren't familiar with the sort of basic aspects of combustion, the air that we are surrounded with and breathe is about 80% nitrogen. When you burn, meaning you're adding oxygen to this, you convert the nitrogen into first a nitric oxide, NO, which then gets further oxidized to NO2 nitrogen dioxide. So essentially, anytime you're burning anything, you're going to get nitrogen oxides from the nitrogen that's in the air. So it really doesn't have anything to do with the fuel. It actually has just to do with the burning process. So our major sources outdoors are vehicles, so motor vehicles, as well as natural gas power plants, especially, or any other, or boilers are also a prominent source. Indoors, gas stoves. We also have space heaters, and then sort of a niche area that I've done a lot of work on is actually ice resurfacers that are fueled by propane, and those also produce high levels in an enclosed indoor space. There's also mechanistic and biological pathways for the inhalation of nitrogen oxides, and what's shown in darker are the pathways where I would say the evidence is stronger, where it can both trigger existing asthma as well as chronic obstructive pulmonary disease, and also can develop asthma, and also links to increased allergic responses, increased airway inflammation, and through an oxidative stress mechanism. So now, to add to this meta-analysis in the same thing, they took a subset of studies, a much smaller number of studies where indoor nitrogen dioxide levels were measured. And again, what you can see here is really essentially effect estimates that span a relative risk of 1. Some indication of increased risk for asthma, but a much less certain, and that led to those conclusions that I showed you before. So the picture is not clear whether nitrogen oxides are the culprit here. And they concluded that gas cooking produces NO2, but also other, as we know, other pollutants such as ultrafine particles. They're finding that association between gas cooking and asthma, but not between NO2 and asthma, suggested that gas cooking may act as a surrogate for other causal variables other than air pollutants produced by gas combustion. And that's also supported by a study conducted in Australia, where there was still an effect of gas cooking on respiratory symptoms, even after adjusting for differences in the measured level of NO2. So there's something else about gas cooking. It could be something else in the combustion, but it also could be, again, the types of homes or the types of individuals that are more likely to use gas for cooking. More recently, so just a few studies that I want to point out. There's been very little, again, new research, but this one is important. It's from the ISAC study, so a very large international survey on asthma and allergy in children. About 500,000 children from 47 different countries. Looked at the relationship between gas stove use and asthma, as well as asthma symptoms, and really nothing going on here. So across the board for wheeze, asthma symptoms, ever having asthma, etc., no associations evident at all. And then this very recent analysis, so I just got this paper from the main authors. This is from the child cohort, so a cohort of around 3,000, birth cohort of around 3,000 individuals across Canada, and then in the 2 communities out of the 4 in Canada where there were measurable levels of gas use or gas stove use in the homes. There's a relationship between higher levels of asthma in homes where gas is used for cooking compared to electricity in Toronto, but actually the opposite in Vancouver. So, which again likely relates to differences in the population and the types of homes that are using gas versus electric homes, age of home, etc. So again, the picture is unclear, and I would say it's muddled. We also have several intervention studies. So, and this relates more to what might we want to do about this problem. This is just looking at levels of NO2. And they took 100 homes with unvented gas stoves, especially low-income homes, and looked at 3 different interventions: electric stoves, putting on a ventilation hood, and adding a combined HEPA filter for particulate matter emissions, as well as activated charcoal that will filter out nitrogen oxides. And I'm showing you the rough costs. So these are both capital and operating costs for the different types of interventions. They measured about a 50% reduction in NO2 levels after 3 months for switching to an electric stove. Of course, you're going to get NO2 from outdoor air as well, so you don't fully eliminate it. Filtration, there were smaller and less persistent decreases, so levels actually went up between 1 week and 3 months. And ventilation hoods in this study were actually ineffective. So you actually saw increases over the course of the intervention. Probably more relevant are the following 2 studies. So this is a study in Australia, 200 children with asthma from 18 primary schools. Now, this is looking at gas heaters, not gas stoves. So gas heaters generally tend to emit higher levels of combustion products and are used for longer periods of time. So they're on for longer periods than a gas stove would be. The intervention was to either switch to electric heaters or to ventilate. And this ventilation is actually putting a flue on it, so it's quite effective. And looking at asthma symptoms, lung function, and bronchial hyperresponsiveness. And all the participants, an inclusion criteria was to have no unvented gas appliances at home, but they may have had vented gas appliances at home. So this showed both quite high levels of nitrogen oxides prior to the interventions, and substantial reductions that coincided with reductions in asthma symptoms, but not with lung function or hyperresponsiveness. So I would say a relatively positive study in terms of asthma symptoms, but not so for these other measures, especially hyperresponsiveness, which is one of the primary sort of gold standard measurements for asthma. And then this very recent publication, it's an older study, but just published last year, and showing in 5 to 11-year-old children in Connecticut with persistent asthma who were living in homes with relatively high levels of NO2. They looked at 2 different interventions and the effect on asthma symptom days. Both a filter that just reduced NO2 and a filter that just reduced particulate matter, but not NO2. They found that in both cases the filters were effective for reducing pollutant levels. The NO2 filtration there was no reduction in symptom days, and for the HEPA filter, particulate matter filter, there was a small reduction in symptom days. So overall, what we tend to be seeing is that there's something going on with gas stoves. It's probably unlikely to be NO2 or NO2 alone, and it may be something related to particulate matter, but again, rather unclear. What else do we know about NO2? NO2, this is from Health Canada's assessment, which is really the most recent comprehensive assessment. The relationship between exposure to NO2 and adverse respiratory effects from controlled exposure studies. These are quite old studies. Anything less than one short-term exposure is less than 1,000 parts per billion, so around quite high levels, but is really unclear. Some suggestions of responses at lower levels for those with asthma or COPD. So it's really focused on individuals with pre-existing respiratory disease, and there's Again, unclear, but some suggestions of responses. Now, I actually got involved in this whole issue. So we had these, again, controlled exposures. So we're adjusting for all other parameters. It's a crossover design. And we were actually wondering if it's not NO2, because we saw really inconsistencies from study to study, could it be something related to reaction products of nitrogen dioxides? And it turns out that there are some very potent ones that can be produced just because of the reaction of nitrogen oxides with surfaces. And they can produce I focus on this quite potent irritant gas called HONO, or nitrous acid. And there's the potential that even though you have these controlled exposures, the inconsistency could have been due to differences in humidity conditions, differences in surface conditions between the controlled exposure facilities that were running these experiments. And then also differences in the effect of NO2 being emitted by appliance in terms of how much of this nitrous acid it could produce from home to home. And I certainly demonstrated that there was a wide variation in the percent of production of nitrous acid. So we then did a controlled exposure study on nitrous acid, and the belief was perhaps this is so potent that it could actually explain all the variation that we were seeing across studies for NO2. Fortunately, that wasn't the case. We saw some very modest effects, but not really enough to explain all the variation across studies. So again, I would say the jury is still out in terms of what exactly is going on, but there seems to be something going on very inconsistently related to gas stove use. Just to summarize again from the Health Canada assessment, this concluded that there was a causal relationship between short-term exposures and essentially exacerbation of symptoms, and likely causal relationship between short-term exposures and a whole host of other outcomes, including cardiovascular and respiratory mortality. I'll come back to this. Long-term exposure and development of asthma or allergic related to disease. So that's really, again, the focus of sort of the current discussion in relation to gas stoves, and suggestive relationship with short-term exposures and cardiovascular effects. Now, most of this information actually comes from NO2 in outdoor air. So NO2 in outdoor air is often used as a marker of what is a very complex mixture of traffic-related air pollution. So if we think the situation from indoor air, where we have indoor chemistry, is complicated and lots of different things at trace amounts besides nitrogen oxides, the situation is much more complex outdoors. So just here you can see sort of coincident with nitrogen oxides, you have carbon monoxide, elemental carbon, you have ultrafine particles, you have volatile organic compounds that all show the sort of the same spatial patterns as does NO2. So that's really the basis of much of the literature that we have. So we have many, many more studies. In general, there's much more consistency. So this is looking at hospitalizations or emergency room visits, and including many studies that we've done here in Vancouver, and other studies done elsewhere in Canada showing this relationship. That's also the basis for these WHO air quality guidelines and these really rather low levels. They're especially driven by this relationship between nitrogen oxides and all-cause mortality. And again, almost all of these studies actually are focused really on the outdoor environment. Also see relationships between nitrogen dioxide and COPD mortality and lower respiratory infection mortality. So again, we're sort of taking information from different pieces and trying to make this story together. And then this is the information that's probably most relevant, which is nitrogen oxides and incident asthma. So that was the basis of that analysis, showing or suggesting about 13% of new asthma cases in the US due to gas cooking. That's really on this outcome itself. It's one that I've worked on a lot. So many of these studies are studies that I've been involved with, both here in Vancouver, elsewhere in Canada, or in Europe. And we see not entirely consistent, but most studies are showing a relationship between nitrogen dioxide exposure and development of asthma. And very importantly, when we looked at this more closely, the effects are almost entirely, in fact, in sort of pooled analysis of a number of birth cohorts, and in individuals that have a particular genetic polymorphism for one of the genes that's involved in sort of detoxification related to oxidative stress. This polymorphism is very common, so it's maybe 40% of the population has it, but that may also explain some of this lack of clarity that we're seeing in relation to gas stoves, NO2, and the effects. So different individuals are definitely responding very differently in the case of developing new onset asthma in relation to their genetic profiles. So really, to sum up, and then I'd really be happy to answer questions. My take on this is that unventilated gas stoves or poorly ventilated gas stoves, there's really no new health information. So we're going all off of studies that were done many years ago. There are small increases in respiratory symptoms and also increases, but I would say very inconsistent in the increases in childhood asthma. It's unlikely to be due to NO2 itself or nitrous acid, HONO. But there's probably real cause for concern, and I would argue impetus for action related to the climate impacts of methane emissions due to, again, this high level of emissions, even when stoves are not actually being turned on. So just the gas itself flowing into the appliance. We know that ventilation, both range hoods and open windows, can reduce, that's a typo, it should be reduced concentrations in the homes, but also lots of variation between the settings in which we have gas appliances. There are lower concentrations with more modern stoves that do not have a continuous pilot light. So my own recommendation would be, if individuals who are likely to be especially sensitive, such as those with asthma or COPD, and you have the means to do so, it is probably not a bad thing to remove a gas appliance and replace it with an electric one. And from a more societal perspective, removing gas appliances due to their climate forcing emissions, especially methane. What do we know about NO2 in ambient air? We see very clearly the short-term exposures and asthma exacerbation. So again, suggesting what we're seeing in some of the studies, while NO2 does seem to link to asthma exacerbation, that may not be the driver for what we're seeing for gas stoves. And that also is supportive of this relationship with asthma, but really it's very likely a marker for a more complex mixture of traffic-related air pollutants. So with that, I'd like to thank you for your attention and be happy to answer any questions that you may have.